Good morning students. In previous video we discussed about coordination number and its value in one dimension, two dimensions and three dimensions, and also we discussed about packing efficiency. Now we are going to discuss about new topic, that is voids or holes. Simply this is also called gaps. Suppose when atoms are arranged like this, that means when atoms are arranged closely, then between the atoms some gaps are present. Suppose see, here I took three atoms. This is one atom, this is one more atom, this is one more atom. I took three atoms. These three atoms present in same layer. Then here see, one gap is present. That means if three atoms are arranged like this, then automatically we get some gap. That is called void. That is also called hole. So what is the definition for void? If atoms are closely packed, then gaps are formed. These are called voids. Here there are two types of voids. One is tetrahedral void, one more is octahedral void. Tetrahedral void, octahedral void. So what is the definition of tetrahedral void? The void is formed between three spheres, that means three atoms of one layer and one atom of another layer is called tetrahedral void. Suppose, see, this is the example for tetrahedral void, because in this structure these dark colored three spheres are present in same layer. This light color circle, nothing but this light color atom is present in different layer. If you put that atom over the gap of these three spheres, then that void is called what? Tetrahedral void. So that is the definition of tetrahedral. Tetrahedral means the void is formed between three spheres of one layer and one sphere of another layer. That another sphere is maybe above layer or below layer, but that should not be in same layer. That gap is called tetrahedral void. Now one more definition for another definition for octahedral void. That is, the gap is formed between three spheres of one layer and three spheres of another layer is called octahedral void. See, again I took three dark circles, that means three atoms present in same layer, then we get one gap. In the below layer or above layer, again we have to take three spheres, then also between them one gap is present. That gap is called octahedral void. Here the gap is formed between three spheres of one layer and one sphere of another layer. Here the gap is formed between three spheres of one layer and three spheres of another layer. That is called octahedral void. So these are the definitions for tetrahedral void and octahedral void. Here the important point is there, that is, if X atoms are present in unit cell, then number of octahedral voids is equal to X. That means number of octahedral voids is always equal to number of atoms present in unit cell. But number of tetrahedral voids is the double the number of atoms in unit cell. This point is important. Some more points there regarding unit cell, that is density of the unit cell. Where density of the unit cell formula is D equal to Zm by Na cube, where D is density of the unit cell, Z is number of atoms belongs to one unit cell. That means, suppose in case of BCC Z value 2, in case of FCC Z value equal to 4, and M is molecular weight of unit cell, N is Avogadro number, A is edge length of the unit cell. This is important formula regarding CBSE level. There are some more formulas, those are important in competitive level. See, in simple cubic unit cell, the neighboring distance between two atoms is 2 are equal to A. Neighboring distance between two atoms means distance between two adjacent atoms, where R is radius of the atom, A is edge length. In case of BCC, its formula is 2 are equal to root 3 by 2A. In case of FCC, its formula 2 are equal to 1 by root 2A. These three formulas are important in case of competitive level, not in CBSE level. Now there are some problems regarding this chapter. First problem is, a compound is formed by two elements X and Y. Atoms of the element Y, that means Y is anion, make CCP, that means Y forms CCP, and those of the element X is cation, occupy all octahedral voids. Then what is the formula of the compound? So in that question, X is cation, Y is anion, Y forms CCP, and X occupies octahedral voids. What is the formula formed between X and Y? That is the question. So given Y forms CCP, let us assume in this type of problems we used to write every time like this, that is, let X is the number of atoms present in CCP, because we don't know how many number of atoms present in CCP. That is why we are assuming that let X is the number of atoms present in CCP. Then number of atoms is always equal to number of octahedral voids. We discussed already just now. So automatically, if X is the number of atoms present in CCP, then Y contains X atoms, then automatically X also contains X atoms, because number of atoms is equal to number of octahedral voids. That is, number of atoms is same with respect to X and Y. See, here also small x and here also small x is there. So automatically both will become cancelled. So finally formula is XY. That's all. That is the way to calculate the model. Next, one more question is given, that is, in a given crystal, Y forms CCP array. X occupies 2 by 3rd of tetrahedral voids, and what is the formula of the compound? In this question also, Y forms CCP, X occupies 2 by 3rd of tetrahedral voids. What is the formula formed between X and Y? So here also same. First you have to write like this, given Y is CCP. Let X number, we don't know how many number of atoms present in CCP. That is why we used to write every time let X is the number of atoms present in CCP. So number of if a number of tetrahedral voids are the double number of atoms present in unit cell. So here number of atoms, how many? X. So Y contains X atoms. Here X occupies 2 by 3, and that means 2 by 3rd into 2x. Why we should write 2x? Because tetrahedral voids are always double the number of atoms present in unit cell. So 2 by 3 into 2x. So finally x into 2 by 3 into 2x, how much? 4 by 3x into yx. Then this x and this x become cancelled. Finally we get x4 y3. So this is the way to calculate this type of model. Next, one more question. See, a compound is formed by two elements M and N. The element N forms CCP and forms M occupy 1 by 3rd of tetrahedral voids. What is the formula of the compound? Again same model. Given N forms a CCP, let X is the number of atoms present in CCP. So automatically Nx, that means N contains X number of atoms. So M occupy 1 by 3rd of tetrahedral voids. Tetrahedral voids are the double. That means 1 by 3 into 2x. So M 2 by 3x into Nx, and finally we get this formula. And one more question is given. This is somehow different compared to previous three problems. So here the question is, a compound forms HCP structure. What is the total number of voids in 0.5 mole of heat? How many of these are tetrahedral voids? So this is the question. One question is given in that one, that compound forms HCP structure. What is the total number of voids in 0.5 mole of heat? How many of these are tetrahedral voids? That is the question. It is somehow logical question. We don't know how many number of atoms present in HCP structure. So let us assume here the number of voids present in 1 mole of HCP. We are assuming is how much? 1. We are assuming like that. Or you can assume 2, 3, whatever it may be. Here I am assuming how much? 1. Then number of octahedral how many? Same, 1. Number of tetrahedral are, it is always double. It is 2. So automatically the total number of voids in 1 mole HCP how much? 3. That means 1 mole HCP contains 3 voids. But we need number of voids in 0.5 mole. 1 for 1 mole 3. For 0.5 that how much? 1.5. How? 0.5 into 3 by 1. That means 1.5. That means 1.5 voids are present in 0.5 mole. That is 0.5 mole contains 1.5 voids. Among these 1.5 voids, 1 is tetrahedral void, 0.5 is octahedral void. Because how can we say that 1 is tetrahedral void? Here 1 mole HCP contains 2 tetrahedral voids. Then 1 mole. Then 0.5 contains how much? 1. For 1 mole 2 tetrahedral voids. For 1 mole octahedral voids 1. For 0.5 mole 1 is tetrahedral void and 0.5 is the octahedral void. So finally one tetrahedral void is present in 0.5 mole HCP. Next one more question is given regarding this one. An element has BC structure with the cell edge. Cell edge means A is given 280 picometers. Its density is also given. How many atoms are present in 208 grams of the element? That means in that question BCC is given, for that edge length is given, that means A is given, density is also given, that means D is given. How many atoms are present in 208 grams of the element? That means 208 grams of the element contains how many number of atoms? That is the question meaning. So in that question density is given, edge length is given. Immediately we have to write this formula, that is D equal to Zm by N equal, where is D is density, Z is number of atoms belongs to unit cell, M is molecular weight, N is Avogadro number, A is edge length. If you substitute by using this formula we can calculate first M is the molecular weight. So yeah, so the formula M becomes this one. If you substitute all these values then we get M value, that is nearly 52 grams. That means what? 52 grams contain Avogadro number of atoms, that means 6 into 10 to the power of 23 atoms. Then 208 grams contains how many atoms? That's all. 52 grams contains Avogadro number of atoms, then 208 grams contains how much? That is the way to calculate these type of models in solid state. There are some more topics regarding this one. We will discuss those topics in next video. Thank you.